Okay, the next question, we have another utility function. It's not as pretty now again as the previous question, but we'll have to attack it. So, what are they asking? Find the marginal rate of commodity substitution, the MRCS for short, for the indifference curve that passes through 355, 650. Now, I'm afraid you'll have to know off by heart your formula for MRCS. So we have MRCS equals, and it's not too bad, it's just the first partial derivative, del u del x1, divided by the second partial derivative. Okay, so like before, we have to find both partial derivatives, and we're going to have to get the number answer for it, and I'm afraid now it's not as clear, but that value, that point there, means x1 is 355 and x2 is 650. Okay, now as before, if you want to, it might be no harm in rewriting that function. I'm going to call x1, I'm going to call it x again, because you'll maybe see it more clearly now why it is a little bit of a better option to do. And x2, I'm going to call it y. Okay, again now throughout the video I'm going to have to just remind people that I renamed x1 and x2, but so if you just keep your head about it, it should be no problem. So I'm going to go down to a new white space on the board, and I'm going to take this down with me. So I need to find, like before, both partial derivatives. So I'm going to rewrite that function in terms of x and y. So I have u of x and y equals 40x plus, I'll not rewrite anything, only the variables x and here and y cubed, minus 7 over x squared all over y. Now, as I said before, there should be warning bells going off. I see square roots, and I see letters on the bottom, or variables on the bottom. Before I even think about differentiating them, I really need to rewrite everything so that there's no square roots and there is no letters on the bottom. So I'm fine here with my 40x, but I'm going to change that to 30x up to the half and leave the y cubed alone. And again, the x squared in the top is fine, but I need to get that y up. So it'll be come up to the top, but it'll have to be changed to y to the minus 1. Okay, so I need each partial derivative, so I need del u del x first. And again, let's just rewrite. Now, you don't have to do this box business. If you're happy enough, you can speed through it a bit more quicker than that. But I'm just going to go with the boxes again. So anything that's not x can go into the box. 40x plus, this time it'll be 30y cubed into the box, and on the outside x up to the half. Again, the box, and x squared will be outside. I'll have 70 y to the minus 1. Okay, so to partial differentiate that with respect to x, I'll have 100, the box on its own, 40. I'll have take the half down in front of the box and take 1 off that half. And again, I go with the calculator if you're stuck on it, but I'll get minus a half. Minus 2 in front of the box, x. Put everything back in the box again, 30y cubed, 70y to the minus 1, and start clean up a little bit. Okay, so I have 40, 30 over 2. Now, if you're stuck, not 100% sure what is a fraction by a number, just again go over and type it in the calculator. A half by a 30, all I'm going to get is a 15, plus 15, and the numbers stay where they are, or the letters stay where they are. Y cubed x to the minus a half. And do what I'm going to do as well, I'm going to just keep everything in alphabetical order. There's no harm. So I'm going to put the x to the half minus a half first, and then the y cubed there. Okay, and again, I'm going to keep alphabetical order. 2 by 70, go with the calculator, you'll get 140 x y to the minus 1. Okay, and if you want to, but you don't have to, but we'll just anything now, any negative power, we're going to put that letter back to the bottom. So what it'll be left with here is 15y cubed on the top and x to the x to the plus a half on the bottom. Now I'm going to do one more further step and change the x to a half to the square root of x on the bottom, and again the same over here, x over y. Okay, now I need the second partial derivative. Okay, so I need del u del y, or again del u del x2 if you didn't change anything. Okay, so retake back down your u. I'm going to copy it down. I'll need a bit more than that. I have that there. Okay, I have u equals that there. I can just see it, that's okay. So I'll just rub out some stuff here. That's fine. Now, so write that, put my major letter this time is y. So anything that's not y now can go in the box. 40x, no y at all there, plus in that box 30x to the half, and y cubed on the outside, and again 70x squared goes into that box, and I'll y the minus 1 outside. Okay, so when I partial differentiate that with respect to y, I'll be left with the box is the same thing as just a number on its own. When you differentiate a number, you're left with nothing. So in this case, when I differentiate a box on its own, I'm left with nothing. In this case, take 3 down in front of the box, and I'll be left with y squared. Put whatever was in the box, keep whatever was in the box inside it. I'm going to have that power to minus 1 is going to come down, but there is a minus there to meet it. So I'm going to have minus minus, and that is going to end up back to a plus. Leave the box as it was and take 1 off the power, minus 2. 70x squared goes in the box. Quickly rewrite that. Numbers with numbers. 3 by 30 is 90. Go with the calculator if you're stuck. Keep everything in alphabetical order. There's no harm. Plus 70x squared, y the minus 2. And again, let's just don't be afraid to, again, that's fine if you want that, that's no problem, but don't be afraid to put negative powers back down. What do I mean by that? There's a y to the minus 2, change that now to x squared over y squared. Okay. Now, what are they saying? The indifference curve that passes through 355 and 650. So what that just means is x1 is 355 and x2 is 650. And now remember, I renamed those to x and y. So really, in this case, in my case, well, from my point of view, x is 355. Y is 650. Okay, so I need to sub them now into the partial derivatives. So I'm going to use the same calculator method again. So I'm going to use the x and y buttons. So I want to, x is 355, so let's 355, store it into x. Y is 650, press in 650, store it into y. Now, so I'm going to I can write in now the two expressions, 40 plus fraction, I'll go back in front of it then, 15, y cubed, so I get to just every time you want them x and y letters, press the pink button beforehand, y cubed over the square root of x. And the great thing about this, you know, you type it as you see it, minus 140 x over y. So remember about a number in front of a fraction doesn't, well, I suppose it doesn't matter. Anyway, it doesn't matter if that 140 goes into the top of the fraction. Just me being picky. Okay, so I get an odd looking number here. You'll probably not get a number like that in the exam, so I wouldn't worry. Just this is I made a bit of maybe a bad example here, so I'll just move the calculator over there. Again, yeah, it's unlikely you'll get a number like that. Anyway, it's no big deal. Sure, it's only a number. So okay, this is it's an odd looking number. It's unlikely you'll get a number like that in an exam. Maybe it's just it's a bad question I made up here. But anyway, it doesn't matter. Just use it. So what we have is that the first derivative del u del x1, but remember I called it del u del x, is equal to 2, just take it down, we'll not worry too much about it, 633,687.7. Right, anyway. Okay, now I need del u del y. So type, there's del u del y, the expression for del u del y, type it in. 90 x up to the half, 1 fraction 2, y squared plus 70 x squared over y squared. Okay, good. Yeah, that's perfect. Again, another silly number. It's just my bad example here. Anyway, again, it doesn't matter. So just take it down, and we have del u del x2, or as I called it, del u del y, equals 71644. Yeah, just that big number there. Okay, right. Oh yeah, sorry, I missed it. There should be a 7 there. Anyway, okay, so are we nearly ready to go? What do we need for MRCS? The first derivative over the second derivative. Okay, so we can take that now. The MRCS equals the first derivative over the second derivative. Remember, that's the first derivative, so I can put that in the top. That's the second derivative of this guy, and put him in the bottom. I'll just write it in and then just bang it in all into the calculator. 218,633,687. Again, sorry for this silly number. 716445916.9. Okay, whatever. Right, throw it into the calculator. We have 218,633,687.7 over 716445916. Yeah, whatever. Okay. 0.3. That's perfect. The next part of the question was, I'll copy it down, I'll put a square around it and copy it down. I had using part A, estimate the change in x1 required to maintain utility at a constant level if x2 decreases by 1 unit. Now you would expect that you would use, like the last question, the small increment formula. Now you are using it, but I'm not going to go into it. Maybe we'll let you check the notes because I don't want the video to go overrun too long. If you read the notes and what they're saying, when the utility is at a constant level, then what happens is that a formula MRCS can be written as minus the change in the second variable divided by the change in the first variable. Now again, I'll let you read the notes to figure why is that, but that's what they're saying. Okay, so all they want us to really do is sub the numbers in. So we know what MRCS was. It was the 0.3. So let's just sub that in. So I know the MRCS. What did they say? Estimate the change in x1. So I don't know that. Required to maintain utility at a constant level if x2 decreases by -1 unit. So I know that. So I'm going to be looking for that there. Okay, so let's sub in what I have. I know from the previous question MRCS was 0.3 equals the minus the change in x2. The change in x2 was decreased by 1 unit, or in my case, remember I renamed these variables. That was the change in y over the change in x. If you renamed the variables, if you didn't, that doesn't make any sense to you. If you did, that does make sense to you. The change in y, or the change in the second variable, was decreased by 1 unit. So that means minus, what was the change here? It was -1. So don't be afraid, that minus must stay, but the change in x2 was -1. And I don't know that there, okay? That's what I don't know. So keep that as the change in x, or the change in x1. Now, what am I going to do here? That may look like an ugly equation, but it's not. If I had 5 equals 7 over x, I'm just going to go to the side of the page here. How would I solve that? I would say take the x up and take the 5 down. Do a swap. I would have x equals 7 over 5. So it's the same idea here. I'm going to swap them terms. The change in x, I'm going to swap that with that there. So I'll have the change in x equals, whoops, sorry for all the colour changes. I'll have minus 1 in the top divided by that 0.3 in the bottom. Again, if you're not 100% sure on how to play about with them signs, just go to the calculator and type what you see. Minus fraction on the bottom, top minus 1, and the bottom 0.3. And it'll end up with 10 over 3. Let's just change that to a decimal place, 3.3. 3.3. So that means the estimate the change in x1, so x1 or x, again, whatever you called it, I better go back, I'll stay with my x here. Y does increase because it's plus 3.3 there. So x increases. If it was a minus 3.3, you would say it decreases, but x increases by 3.3 units. Okay.